In this module, we will study the long-run production function where it is assumed that the production depends on two inputs, namely labor and capital, and where both these inputs are variable in nature. We will also see how the changes in the labor and capital lead to a change in the output. But before, it is important to understand the concept of isoquant. Like the indifference curve, isoquant is made up from the points of view of producer, and it is an important tool for measuring the producer equilibrium or the equilibrium of a firm. Let us understand it in detail.
Learning outcomes. After studying this module, you shall be able to know the concept of isoquants and its assumptions and properties, learn how to measure the equilibrium of a firm or producer equilibrium, identify the meaning of MRTS and elasticity of substitution, know the concept of returns to scale. Let us begin with isoquant, its assumption and properties. Isoquant means equal quantity. Isoquant is therefore known as the production indifference curve or equal product curve. As the name itself suggests, an isoquant is the locus of all those combinations of inputs which yield same output. Hence, all the points on an isoquant represent different combinations of labor and capital which can be used to produce the same quantity of output. Now, the question is that how the different combinations of inputs can yield the same output. The answer to this question is that since there are different techniques of production available in the world, thus the different techniques of production requires different combinations of inputs, and thus it is possible to produce the same level of output using different combinations of inputs and techniques of production. The assumptions for deriving an isoquant are as follows. There are only two inputs or factors, that is labor and capital, to produce a commodity X. Labor and capital can be substituted for each other up to a certain limit at a diminishing rate of substitution. The production function is continuous in nature, indicating that both labor and capital are perfectly divisible in nature and can be substituted in any small quantity. Consider the capital-labor combination and output table. As it is quite clear from the table that different input combinations, that is point A, B, C, D, yield the same level of output 100. Thus, an isoquant should pass through these points. Moreover, both inputs are substitute for one another. Now, based on all these, we can draw the isoquant as represented in the diagram. IQ1 yields the same level of output, that is 100 units of X using different combinations of L and K. But it is important to note here that the movement from point A to D indicates an increase in the employment of labor and reduction of capital in the production process. This clearly indicates that labor and capital are perfect substitutes for each other, as same quantity of X can be produced by either more of labor or less of capital, or by more of capital or less of labor. A higher isoquant represents higher output produced using more of both labor and capital combinations, as represented by IQ2 in the diagram, which is yielding 200 units of X. Now, let us study the difference between an isoquant and an indifference curve. An isoquant is analogous to an indifference curve in more than one way. In it, Two factors, that is capital and labor, replace two commodities of consumption. An isoquant shows equal level of product while an indifference curve shows equal level of satisfaction at all points. The properties of isoquants, as we shall study, are exactly similar to those of the indifference curves. However, there are certain differences between isoquants and indifference curves. Firstly, an indifference curve represents satisfaction which cannot be measured in physical quantity. In the case of an isoquant, the product can be measured in physical units. Secondly, on an indifference map, one can only say that a higher indifference curve gives more satisfaction than a lower one. But it cannot be said how much more or less satisfaction is being derived from one indifference curve as compared to the other, whereas one can easily tell by how much output is greater on a higher isoquant in comparison with a lower isoquant. Now, let us look at the properties of isoquant. Negative slope of isoquant. The negative slope of the isoquant implies substitution of one input for another so that the output remains the same. It means that if one of the inputs is reduced, the other input has to be increased that the total output remains unaffected. Moreover, an isoquant is always negative in the economic region where the substitution between the inputs is technically efficient. Convexity. Isoquants are convex to origin because of the diminishing marginal rate of technical substitution. Here, marginal rate of technical substitution implies the rate at which one input is substituted for the other input at different levels without affecting the total output. Symbolically, MRTS is equals to minus change in K divided by change in L is equals to the slope of the isoquant. MRTS is always diminishing because of the following two reasons. 1. No factor is a perfect substitute for another. And second, inputs are subject to diminishing marginal return. Hence, if we increase the employment of labor by 1 unit, then it leads to a decrease in the capital, and this decrease in the capital reduces with the employment of more and more labor by 1 more unit, keeping the output level same. Thus, MRTS is diminishing in nature. Moreover, the isoquants never intersects with each other and are never tangent to each other. Else, there will be two possibilities. First, the same combination of inputs can produce two different quantities of the same commodity. And second, a given quantity of a commodity can be produced with a smaller as well as a larger input combination.
For instance, consider the figure. If the isoquant are such, then point M represents that the same level of combination of labor and capital can produce two different levels of output, 100 and 200. Moreover, if we look at point K and point J, then both of them represents that L2 unit of labor with more of capital is yielding 200 output and L2 unit with less of capital is yielding 100 output. Hence, both of these conditions are violating the assumptions of isoquant. Hence, we conclude that due to the problem of inconsistency, isoquant neither intersects nor tangent to each other.
Additionally, higher isoquant represents a higher level of output produced. This is because any combination on the higher isoquant comprises of larger inputs combinations which will in turn produce higher level of output.
We shall now discuss the isoquant map and economic region of production. Isoquant map is a set of isoquants like IQ1, IQ2, IQ3 and IQ4 in the figure, where each isoquant shows different outputs produced by different combinations of labor and capital. It is important to note here that neither an isoquant nor an isoquant map is technically efficient because the MRTS on an isoquant decreases and reaches to 0. This means that 0 MRTS marks a limit to which one input can be substituted for another, and it also determines the minimum quantity of an input required for the production of an output. Beyond this point, it becomes important to employ both inputs for the production of the output, as the substitution between inputs does not take place anymore beyond this point. Such a point where MRTS is equal to 0 can be determined by drawing a tangent on the isoquant such that it is parallel to both the axes. In the diagram, MRTS is equal to 0. It is represented by the dashed lines. Hence, points A, B, C, D, E, F, G, H are the points where MRTS is equals to 0 and one input cannot be substituted for another anymore. That is, the minimum amount of one input required for the production of the other. When we join points A, B, C, D, we get an upper ridge line OM, and when we join points E, F, G, H, then we get a lower ridge line ON. The upper ridge lines shows that the marginal productivity of capital is 0 on OM, whereas the lower ridge line shows that the marginal productivity of labor is 0 on ON. The area outside these ridge lines are the technically inefficient area where production cannot take place. Hence, the area which is technically efficient and where the production can take place is the area between the ridge lines, which is also known as the economic region. Thus, any production technique or any combination of labor and capital within this economic region is technically efficient to produce output.
Let us learn about elasticity of technical substitution. MRTS is the slope of an isoquant and depicts the rate at which one input is substituted for the other, but it does not determine the degree of substitution between these inputs. Elasticity of technical substitution is the only measure which determines the substitutability of factors or inputs. Elasticity of technical substitution is defined as the percentage change in the capital labor ratio divided by the percentage change in the MRTS. Symbolically, elasticity of substitution is equals to percentage change in K by L divided by percentage change in MRTS, or it is equals to delta K by L divided by K by L, the whole divided by delta MRTS by MRTS. Since throughout an isoquant both K by L and MRTS moves in the same direction, therefore the value of the elasticity of substitution is always positive. Moreover, the value of elasticity of technical substitution depends on the curvature of the isoquants. It varies between 0 and infinity depending on the nature of the production function. Production function determines the curvature of the various kinds of isoquants. Let us now move ahead and talk about the law of returns to scale. When both the inputs become variable and the change in both the inputs affect the change in the output and correspondingly the size of the firm changes, then it is known as the law of returns to scale. It is a long run phenomenon where the supply of both labor and capital is elastic. When both labor and capital are increased proportionately or simultaneously, then there are possibly three ways in which output can be increased. 1. Output may increase more than proportionately to an increase in inputs. 2. Output may increase proportionately to an increase in inputs. 3. Outputs may increase less than proportionately to an increase in the inputs. Correspondingly, there are three types of returns to scale. First, when output increases more than proportionately to an increase in inputs, then it is known as increasing returns to scale. For example, if labor and capital both increase by 50% and correspondingly the output increases by more than 50%, then it is known as the increasing returns to scale. Consider the figure. As represented in the diagram, 10 units of output depicted by IQ1 is produced using 1 unit of labor and capital, but when the labor and capital were doubled, that is, to 2 units each, then the output depicted by IQ2 increased more than double, that is, to 25 units. Similarly, when the labor and capital were again increased by one more unit, then the output depicted by IQ3 was increased to 50 instead of 30 units. Increasing returns to scale happens because of the economies of scale. The different type of economies of scale which lead to increasing returns of scale in a production process are technical and managerial indivisibility. Since it is difficult to divide any machine or technique in fractions, therefore there is always a minimum amount of employment, machine, and technique which are required for the production and which are indivisible in nature. When these inputs are increased, then they increased the production exponentially and hence increasing returns to scale take place. Higher degree of specialization. When the labor is specialized for a particular production technique or process, then its productivity increases, leading to an increase in the output per labor. This leads to increasing returns to scale. Dimensional relations. For example, when the size of a room 15 into 10 inches is equals to 150 square feet is doubled to 30 inches into 20 inches, the area of the room is more than doubled. That is, 30 into 20 inches is equals to 600 square feet. When diameter of a pipe is doubled, the flow of water is more than doubled. Following this dimensional relationship, when the labor and capital are doubled, the output is more than doubled over some level of output. Second, when output increases proportionately to an increase in inputs, then it is known as constant returns to scale. For example, if labor and capital both increase by 50% and correspondingly the output also increases by 50%, then it is known as constant returns to scale. Consider the figure. As represented, 10 units of output depicted by IQ1 is produced using 1 unit of labor and capital. But when the labor and capital were doubled, that is, to 2 units each, then the output depicted by IQ2 also doubled, that is to 20 units. Similarly, when the labor and capital were again increased by one more unit, then the output depicted by IQ3 was increased to 30. The constant returns to scale happen because there is a limit on economies of scale. When economies of scale disappear and diseconomies are yet to begin, the returns to scale become constant. The diseconomies arise mainly because of decreasing efficiency of management and scarcity of certain inputs. Moreover, constant returns of scale appears when the factors of production are perfectly homogeneous, like the Cobb-Douglas production function. When output increases less than proportionately to an increase in the inputs, then it is known as decreasing returns to scale. For example, if labor and capital both increase by 50% and correspondingly the output increases by 30%, then it is known as decreasing returns to scale. Consider the figure. As represented, 10 units of output depicted by IQ1 is produced using 1 unit of labor and capital, but when the labor and capital were doubled, that is, to 2 units each, then the output depicted by IQ2 did not double. That is, it increases to 18 units instead of 20 units, and so on. Decreasing returns to scale happens because of diseconomies of scale, mainly when there are managerial diseconomies and the size of the firm expands, managerial efficiency decreases, causing the decrease in the rate of increase in output. Moreover, when the natural resources exhaust in nature, then also decreasing returns of scale appears. For instance, if the coal mines are doubled, then it may be possible that the coal production would not be doubled, rather it just increases by less than double because of the limitness of the coal deposits or difficult accessibility to the coal deposits. We shall now discuss production function and returns to scale. Suppose the production function is given by Q is equals to F bracket K comma L bracket close. Now let us assume a Cobb-Douglas production function which is homogeneous of degree 1, which in turn means that when all inputs are increased in the same proportion, and this proportion can be factored out. For instance, if all the inputs are increased in a proportion by h, and if output will also increase by h, then the production function is said to be of homogeneous of degree 1. This is also known as linear homogeneous production function, and it implies constant returns to scale. Such a function can be expressed as HQ is equals to F bracket H into K comma H into L bracket close. HQ is equals to H into F bracket K comma L bracket close. However, if all the inputs are increased in the same proportion by H, but the output do not increase by that proportion, then in such a case, a production function may be written as K into Q is equals to F bracket H into K comma H into L bracket close, where K denotes K times increase in output as a result of H times increase in both the inputs. Hence, K may be greater than H or equal to H or less than H. If K is greater than H, then it represents an increasing returns to scale. If K is equals to H, then it represents constant returns to scale. And if K is less than H, then it represents decreasing returns to scale.
Now, let us summarize whatever we have learnt in this module. It can be concluded that both the returns to a variable factor and returns to scale are compatible because returns to a variable factor prevails in the short run, where the production can be increased by increasing the variable input only, and the capital is fixed in nature. On the other hand, the returns to scale is a long run phenomenon, as all the inputs used becomes elastic and variable in the long run, and therefore production can be increased in the long run by increasing all the inputs. Moreover, depending upon the types of production function, both these laws can also exist simultaneously, but that is not a usual phenomenon.